Now, simultaneous first order linear differential equation. So if we have more than one linear differential equation of first order, then how can we able to solve that system of equation? Simultaneous equation is equivalent to system of equation. The differential equation, the differential equation of the form f1 of dx plus c1 of dy equal to h1 of t f2 d of x plus g2 d of y equal to h2t. So together is called simultaneous equation where f1, f2, g1, g2 are polynomial, or you can say are polynomials or function polynomial of d, where d is nothing but d by dt, derivative with respect to t, is called simultaneous first order linear differential equation. Here you remember that if f1 d, g1 t, f2 d, g2 d determinant is 0, then we can say two equations are dependent. Two equations are dependent, or the system is dependent. If they are non-zero, then only we can find the value of the unknowns x and y. Here you see that we are having two unknowns x and y and two equations h1 and h2. So what we will do here actually is we can eliminate any one of the variable x and y first, and we will try to get the solution for the other variable. After getting the solution of the other variable, we can substitute back in the given equation and we can try to reconstruct the solution of the next variable. So this is the process we will follow and we will try to find the solution. But simply we can take a simple example here. Example, solve dx by dt minus y equal to 0 and dy by dt plus x equal to 0. Here we take d by dt as d, and so we can see that we can write this one as dx minus y equal to 0 and dy plus x equal to 0. So f1d is nothing but d, g2d is nothing but d. So these are polynomial of d. Now these two equations are called together simultaneous differential equation because we are having two variables and two equations. So these are called simultaneous equation. Remember, whatever solution we will get whatever values of x and y will get, those two values should satisfy both the equations simultaneously. It is not like that it will satisfy the first equation but not second. Then we cannot say it is a solution. Whatever value of x and y you will get, that value should satisfy both the equation simultaneously. Okay, so now this is my system of equation or simultaneous equation. Now we want to solve this. We want to solve this. As I told you, if you are getting the system of equation, first of all, try to eliminate either x or y. Whatever thing you want to eliminate, you can eliminate. That is not a problem. Suppose you are eliminating y, then you try to construct the value of x. After getting the value of x, you can put either first equation or second equation and you try to get y value. That is the thing we will do. So let me denote it as equation 1. Let me denote it as equation 2. Now suppose we will try to eliminate y from both the equation. So if I try to eliminate both the, if I want to eliminate y, then what I will do, I will multiply equation by d, equation 1 by d, and I will add with equation 2. I will add with equation 2. So that what will happen? If I multiply equation 1 by d, I will get d into d square x minus dy. This is 1 into d, and plus is there, then 2. 2 means dy plus x equal to, right hand side will be also 0 because 1 0 into d is 0 plus this is 0. So finally what you will get, minus dy plus dy will get cancelled, and so d square x plus x equal to 0. Now you see that x is common, so d square plus 1 of x equal to 0. Now here my dependent variable is x and d is nothing but d by dt. So this is a constant coefficient differential equation, homogeneous of course. And so what will be the auxiliary equation? Auxiliary equation will be m square plus 1 equal to 0. And so what will be my m? M will be plus or minus I. So the nature of the roots is real and, sorry, complex. So what will be my complementary function? That complementary, here no need to find pi because right hand side is 0. The complementary function will be nothing but the solution x. Complementary here dx by dt. So solution will be in terms of d, and so that one will be c1 cos t because beta is 1 plus c2 sin t. Okay, and the real part is 0, e to the power 0 into t, so that will be 1, so c1 cos t. So this is the value of xt you got. This is the value of xt you got. Now how to x you got. Now how to find the value of y? You know, from the first equation here, dx by dt minus y equal to 0. So what will be your y? From the first equation, from the first equation, we know, what do we know? Dx by dt minus y equal to 0. That means y equal to dx by dt. But what is our x? Our x is c1 cos t plus c2 sin t. So this means y equal to d by dt of c1 cos t plus c2 sin t, because x equal to c1 t plus c2 sin t. And what is the derivative of the derivative of cos is minus sin, so minus c1 sin t, and then derivative of sin is cos plus c2 cos t, and this is nothing but y of t. Hence The solution of the simultaneous equation is x equal to c1 cos t plus c2 sin t and y equal to minus c1 sin t plus c2 cos t. You put these two values in the equation, you can check that it will satisfy identically. Hence, these are the solution of the simultaneous differential equation. Let me take another example here. Let me take here. Solve solve dx by dt plus y equal to e to the power t. Here you remember x and y are dependent variable, t is the independent variable. So the solution x and y we will find in terms of t. And next equation is x minus dy by dt is equal to t is equal to t. So in other word, in form of d, how can we write it? We can write it in this way: d of x plus y equal to e to the power t, and x minus d of y is equal to t. So here right hand sides are non-zero. So let me denote it as equation 1, let me denote it as equation 2. Suppose here minus is there, so let me first try to eliminate y. So what I will do, I will multiply equation 1 by d. So d into equation 1 plus equation 2. So d into equation 1 means d into dx plus y, okay, dx plus y and plus x minus dy. And what will happen to the right hand side? D I am multiplying with 1. So d of e to the power t minus plus 2. 2 is t. Now you see that capital D is nothing but d by dt. Capital D is nothing but d by dt. And so what we will get here? D into d square of x and plus d of y plus x minus dy is equal to d of e to the power t means derivative of e to the power t. D of e to the power t means d by dt of e to the power t. And so derivative of e to the power t is e to the power t plus t. And finally what we will have? Dy will get cancelled. D square plus 1 into x equal to e to the power t plus t plus t. And here we can find the auxiliary equation. First we will solve for x. For solving x we will write the auxiliary equation m square plus 1 equal to 0, m equal to plus or minus I, and so the will be nothing but complementary function will be nothing but say c1 cos t plus c2 sin t. This is your complementary function. This is not the final x. So because here the right hand side is non-zero, so we need to find pi. What is the pi? We'll find here pi equal to 1 by d square plus 1 into e to the power t plus 1 by d square plus 1 into t. So this is like a polynomial function, this is like an exponential function. So exponential function means d will be equal to 1. So 1 by 1 square plus 1 plus 1 e to the power t. And here this is polynomial function. So 1 plus d square to the power minus 1 into t. And so finally what we will get? 1 by 2 e to the power t, and this expansion will be 1 minus d square plus d to the power 4 and so on, so t. So the degree of t is 1, so d square, d4, all those things will be 0. So only one t will be there. And so finally pi will be e to the power t by 2 and plus t. So this is your pi. Once after getting the pi, you can write the complete solution x of t. Not we are not finding the value of y so far. So we are finding x of t. X of t will be nothing but cf plus pi. And so cf is nothing but, what is my cf? C1 cos t. So C1 cos t plus C2 sin t, and pi is nothing but plus e to the power t by 2 plus t. So this is my value of xt. After getting the value of x, we can able to find the value of y by substituting this in any one of them. Suppose I will substitute in y, my first equation. I will substitute in first equation. First equation is dx plus y equal to e to the power t, and so y will be nothing but e to the power t minus dx. So that means e to the power t minus d of c1 cos t plus c2 sin t, and then plus e to the power t by 2 plus t plus t. And if we differentiate it, e to the power t, d means derivative, d means here d by dt. And so if you differentiate it with respect to t, minus derivative of cos is minus sine, so minus minus will be plus c1 sin t. Derivative of sine will be cos, minus is there, minus c2 cos t. Derivative of e to the power t is e to the power t plus e to the power t by 2. Derivative of t is 1, and so this will be minus and minus 1. Now these two things are similar, so you can, this is minus, so you can just simplify these two, and you will get e to the power t by 2 plus c1 sin t minus c2 cos t minus 1. So this is the value of y of t. This is the value of y of t. So like this we can able to solve the simultaneous equation. So I will do another problem here, and then we will think about the next problem. So next example is, suppose the equation is in this form. Solve dx by dt plus 2x minus 3y equal to t, and dy by dt minus 3x plus 2y is equal to e to the power 2t. Okay, so this simultaneous equation you can write in the form as like this: dx plus 2x minus 3y equal to t, and dy minus 3x plus 2y equal to e to the power 2t. You see that x is common between these two, so I can take, write this one again, rewrite it as again d plus 2 of x minus 3y equal to t, and y is common between these two, so I can say d plus 2 of y minus 3x equal to e to the power 2. Okay. So now we can eliminate any one of them, either x or either y, both the things are same. And so what we will get then, suppose this is my equation 1 and this is my equation 2, and suppose I want to write eliminate y, then I will say t plus 2 into 1, d plus 2 into 1 plus equation 2. So what will happen? D plus 1. D plus 1 means d plus 2 into d plus 2 of x, and then minus 3 into d plus 2 of y. This is the left hand side. Similarly, the left hand side here is, so 2 into 3 I will do. 2 into 3. So plus 3 into d plus 2 of y minus 9x. This is the left hand side, and the right hand side will be this one. I am differentiating with respect, multiplying with d plus 2 of t, and this one I am multiplying 3 plus 3 into e to the power 2, e to the power 2t. So finally what will happen? You see 3 into d plus 2y, 3 into d plus 2y will get cancelled, and remaining thing will be d plus 2 whole square x and minus 9x will be derivative of t is 1, 2t. So 1 plus 2t plus 3 into e to the power 3 into e to the power 2t. So now what I will do here, I will expand this one. D square, so I will write here d plus d square plus 4d plus 4 minus 9 of x equal to 3 e to the power 2t plus 1 plus 2t. And so what I will get here, d square plus 4d minus 5 of x equal to 3 e to the power 2t plus 1 plus 2t. So here we have to find pi as well as cf. So in order to find cf, what I say, I will write auxiliary equation m square plus 4m minus 5 equal to 0, equal to 0. So we can write here m square plus 5m minus m minus 5 equal to 0. So m plus 5 into m minus 1 equal to 0, equal to 0. And that implies m equal to 1 and minus 5, which is real and distinct. And so we can write the complementary function for x is c1 e to the power t plus c2 e to the power minus 5t. This is your complementary function. Now let us find the pi for xt. pi for x. Pi for x is 1 by d square plus 4d minus 5 3 e to the power 2t plus 1 by d square plus 4d minus 5. 1 means e to the power 0 into t plus 1 by d square plus 4d minus 5 into 2t. So there will be three pi's. So we will find one by one. This one will be wherever d is there, you put 2. So 4 plus 4, 4 plus 8, 12 minus 5. 12 minus 5 is 7. So we can have 3 by 7 e to the power 2t. And here the d is 0, minus 1 by 5, minus 1 by 5, e to the power 0 t is 1, and then plus I will take 2 common outside, and I will take minus 5 outside, so that 1 minus d square plus 4d by 5 into t, into t. And so what we will get, 3 by 7 e to the power 2t minus 1 by 5 plus, so you can say minus 2 by 5 into 1 minus d square plus 4d by 5 inverse into t. Now only first order derivative we need here, second order and onwards it will be 0. So we can have 3 by 7 e to the power 2t minus 1 by 5 minus 2 by 5 into t, and then minus 4 by 5, minus 4 by 5, and so 3 by 7 e to the power 2t, and then minus 2 by 5 t. Then what will happen? Minus 1 by 5 plus 4 by 5. 4 by 5 minus 1 by 5 is 3 by 5. So plus 3 by 5. So this is your PI. This is your PI. So you have the complementary function of x as well as the particular integral. So what will be the total thing then? Complementary function c1 cos t, sorry, c1 e to the power t. So the complementary function is c1 e to the power t plus c2 e to the power minus 5t, and then pi for this one is plus 3 by 7 e to the power 2t minus 2 by 5t plus 3 by 5. So this is the value of x of t. Once after getting the value of x, now you can find the value of y. From where you can substitute the value of x in equation 1. Equation 1. So what will you get? Equation 1. Your equation 1 is nothing but, your equation 1 is d plus 2 of x, or you can say dx by dt, dx by dt plus 2x plus 2x minus 3y equal to t, and dx by dt means derivative of x. Derivative of x here we will have, so that means dx by dt plus 2x minus t equal to 3y, equal to 3y. Now you find here dx by dt. What is the d by dt of, what is the xt? Xt will be nothing but c1 e to the power t, c1 e to the power t plus c2 e to the power minus 5t, and then plus 7, 3 by 7 plus 3 by 7 e to the power 2t, 2t, and then minus 2 by 5t minus 2 by 5t, and then plus 3 by 5 plus 3 by 5. This is x plus 2 into 2 into x. X is again c1 e to the power t plus c2 e to the power minus t 5t plus 3 by 7 e to the power 2t minus 5 2 by 5 t plus 3 by 5, and minus t equal to 3y. So from here you can get the value of y. From here you can get the value of y. So how can you get? So y of t equal to 1 by 3 whole into differentiation of e to the power t is e to the power t, differentiation of e to the power minus 5t is minus 5 c2 e to the power minus 5t, and differentiation of this one will be plus 6 by 7 e to the power 2t, and differentiation of this one with respect to 2 will be minus 2 by 5, and then let me go to find 2c1 e to the power t and plus 2c2 e to the power minus 5t and then plus 6 by 7 e to the power 2t and minus 4 by 5t plus 6 by 5 and minus t and minus t. Okay, so this will be your y of t. Now you can simplify. You see e to the power t is here and e to the power t is here. So c1 is common. C1 plus 2c1 means 3c1. So we can have 1 by 3c1 e to the power t and minus 5c2 and plus 2c2. So 3. So minus 3c2 e to the power minus 5t. Here 6 by 7 e to the power 2t. Here 6 by 7 e to the power 2t. Okay, sorry. This one, yeah. So this one will be wrong. What is the thing here we will get is, you see, here 1 by 3, there 2. So 1 by 3 plus 2 is 7 by 3. 7 by 3 C1 e to the power t. And here minus 5 by 3 and there 2. There 2. So minus 5 by 3 plus 2. So 1 by 3 plus 1 by 3 C2 e to the power minus 5t and here 2 by 7 and here I am having 6 by 7. 2 by 7 plus 6 by 7 is 8 by 7 plus 8 by 7 e to the power 2t and then here I am having minus 2 by 15 and here I am having 6 by 5. So here I will 2 by 15 minus 6 by 5. So that means 2 minus 18 by 5. So 2 minus 18 means minus 16 by 5. Minus 16 by 5. And then what is the remaining thing? So this is over. And then 2t over t. Now what is the remaining t? Remaining t will be minus, so minus 9 by 5 minus 9 by 5 t. So once more you can rearrange them and you can write as it is. So y of t will be, you can say 1 by 3 e to the power minus 5t plus 8 by 7 e to the power 2t plus 7 by 3 e to the power t c1 and this is c2 and then next one will be minus 9 by 5t and minus 16 by 5. So if you put these values in the given equation, definitely it will satisfy. If it is not satisfying, then it will be not called as a solution. So like this we can able to solve the system of differential equation.